Good morning, my name is Matthew Hayward, and today I'm presenting my final project, Domain Adaptation of Lightweight LLMs for Scientific Lay Translation. I'll be demonstrating how a QLoRA approach allows us to fine-tune models directly on consumer-grade hardware to transform dense research abstracts into engaging journalism. So as a computational biologist, I've seen how high-impact microbiome research often stays trapped behind a jargon barrier. Traditional science journalism is simply just too slow to bridge this gap, leaving public perception to be shaped by marketing rather than evidence. My solution is to bypass these bottlenecks with an automated pipeline. By fine-tuning a scientist-journalist persona, we can autonomously monitor PubMed, where all scientific abstracts are deposited, and instantly translate them into these dense abstracts into vivid, social media-ready summaries, delivering accurate science directly to the public in real time. And beyond this communication barrier, we face a looming resource squeeze. As AI companies pivot towards profitability, the subsidized cloud credits we enjoy today will likely vanish, making massive models inaccessible for many researchers. Further, the environmental footprint of centralized data centers is becoming untenable. By fine-tuning specifically on consumer-grade hardware, we provide a sustainable alternative, and this ensures that powerful scientific tools remain accessible, affordable, and private, and protecting the future of open science regardless of shifting corporate interests. So to make this reproducible for others, I've treated my Lenovo laptop with its 8GB RTX 4060 as a benchmark for consumer-grade constraints. The goal wasn't just to make it work, but to optimize setup so anyone with a standard gaming laptop could do this. The secret sauce here is the combination of 4-bit and F4 quantization and gradient checkpointing. These strategies paired with paged AdamW optimizers allow me to bypass the dreaded out-of-memory errors that usually plague 8GB cards. And for those looking to replicate this, I've streamlined the installation into a single conda environment, ensuring the GPU is correctly registered from day one. And you can find this detailed instruction in the README that's deposited in the code directory with this submission. The engine of this project starts with PubMed. It's programmatically accessed, allows for a daily automation cycle. So for example, we could imagine fetching research at 10 AM and instantly prepping it for translation. I used the search terms human and microbiome. However, you could change this to anything, any field of interest, and it will, you can just rerun the whole model and it will generate the same, summary template, and it will be field specific. Once I had the abstracts from PubMed, I used OpenAI's API to distill this 6,000 abstracts into a science journalist persona. So you see here. So this was a strategic expansion over what I mentioned in my project design. So I pivoted to a Llama 3 billion parameter model, and this allowed me to triple my training volume without hitting this VRAM limit. So if you're interested in the logistics of the entire process from the initial API calls to the final formatting, is fully documented in the accompanying Python notebook called Download and Building Train Dataset, included with this submission. So moving to training itself, you can see the prompt style is deliberately minimal. I kept the instructions simple because I wanted to test a specific hypothesis. Can the lightweight 3 billion parameter model internalize a complex journalistic schema just from the training data without being the hand-holding that I gave ChatGPT? And this, the movement from a 3 billion, from 8 billion to a 3 billion model allowed me to also pivot in another sense from 312 tokens to 512. So I had actually started working on this early on, and I was okay chopping back the tokens, but silly on my behalf, I didn't realize early on that I was actually cutting into the summary part of my prompt, which is kind of the whole point of this project. So actually moving to the 3 billion allowed me to capture the abstract and the summary for the majority of the abstracts in my training dataset. You'll also notice here, well actually I put it in the last slide, that I gave the OpenAI teacher only 200 tokens to make the summaries, but I'm giving the training prompt 400. I really want to see if the pithiness of ChatGPT is captured in the fine-tuned model, and then I want to see if the untuned model just rambles, basically. So to fit this on my computer, I used QLoRA. So I froze the 3 billion base parameters and then modeled with a 4-bit precision and training these lightweight adaptive matrices in parallel. So pivoting from 8 billion to 3 billion model was my turning point. It gave me the memory headroom to double my adapter capacity. So I increased the rank and the alpha to 32. While I know standard summarization often succeeds at rank of 8, I found that translation, specifically the microbiome jargon, into this 8th grade scientist that I was trying to imagine, requires a much higher capacity to model these complex stylistic shifts. And finally, because I'm training for 5 full epochs at this higher rank, I introduced a 5% dropout layer as a gradual, as a guardrail to ensure my model generalizes to new research rather than simply memorizing the trainer set. So this slide represents the technical core of the project and the training loop. It is only a single slide, but it's incredibly important, and you can see it has many parameters. So my primary goal was to prove that you don't need a massive computer cluster to achieve a high quality domain adaptation. So by using one of these trainers, the SFT trainer, with like a highly deliberate optimization, I brought the training time down from a projected 48 hours to just 3.5 hours. So to stay with my 8 gig VRAM limit, I used a micro batch size of just 1 with 4 gradient accumulation steps. And this gave me the stable global batch size of 4 without triggering out of memory errors. I also utilized the paged Adam W 8-bit optimizer, which intelligently offloads data to the CPU when the GPU is saturated. As you can see in the loss curve, the model converged beautifully. I used a 3% linear warm-up to prevent early gradient divergence. And by tracking the validation loss, I was able to automatically restore the best performing checkpoint from epoch 3 just before the model began to overfill. And this ensures the final model remains generalized enough to handle new and unseen abstracts. So now on to the quality of the output, the really interesting bit. How did it do? So to see if the adapters actually mastered the journalist persona, I ran a direct head-to-head comparison between my fine-tuned Llama model and the GPT 4.0 mini teacher, science journalist. So it's important to note that the test prompt here is identical to the training format, but with the response just left out. So this leverages the model's autoregressive nature to just predict the next token, which I think is incredibly nifty and pretty cool. The results I think here that you can see are very striking. The LoRa adapters didn't just capture the facts, they successfully internalized the concept of main result and impact schema. You can see marked in green. And the fine-tuned model consistently reproduced the punchy, high energetic tone of the teacher, proving that even a lightweight 3 billion parameter model can achieve high semantic fidelity and professional readability when the stylistic adapters are sufficiently high capacity. So this slide illustrates exactly why base models fail our mission of accessibility. At the bottom, you see the untuned response. While it's factually accurate, it's dense, full of clinical jargon. I think the term like vancomycin-resistant enterococcus is quite alienating, and to me, that's like reading the newspaper. But that's after 20 years of working in this field. I realize that just sounds like another language to most people. I suppose it is in part. Latin, maybe Greek. So in contrast, my QLoRA tuned model on top takes the same complex findings and translates them into a clear, engaging narrative. So by prioritizing the human impact over academic terminology, I think it produces something that's both interesting and engaging and not alienating. So let's get on to the numbers. So to validate the success of the fine-tuning, I analyzed the generated profiles, and then I took the data and looked for these behaviors. So let's go through these figures. In panel A, you can see the base model in yellow consistently hit the 400 token ceiling, so it essentially just rambled on. And in contrast, the QLoRA model in blue developed precise length control, which I thought was really fascinating. It really hung around this 72 token level, even though I gave it 200, which I think is super interesting. It learned to prioritize the end sequence token much earlier, so that's very cool, and proven it internalized the pithy nature of my ChatGPT journalist. More importantly, panel B and C showed the adapters implicitly mastered the structural headers, main result, and impact, and the 3-sentence length in 100% of cases. So that's really surprised me, and I thought that was fantastic. And this was without explicit instruction. We saw that in the prompt it's heavily reduced, so I thought it was very cool. And then finally, panel D, we see that there's a leap in lexical diversity, and it confirms that the model didn't just get shorter, it actually absorbed this richer language and the more engaging vocabulary of GPT-4, allowing it to map complex microbiome science to a lexicon that is far more accessible to a general public. So finally, we look at the field standard metrics to prove the shift, but these are statistically significant, which is fantastic. In panel A, we see the Fleisch-Kincaid grade level. My model successfully dropped the reading register from postgraduate level down to accessible 8th grader standards. That's fantastic. So mission accomplished. And this is a dramatic improvement, as you can see, over the base model. And then to ensure the quality of the simplification, panel B shows the SARI score. So this metric tracks how well a model adds, deletes, and keeps words to make text clearer. And my fine-tuned model achieved an exceptional median score of 62. It's a massive 25-point leap over the base model, proven a vastly superior capacity to restructure prose. And then crucially, panel C shows we didn't just sacrifice accuracy for simplicity. Using the BERT score, we measured semantic similarity through contextual embeddings. My model achieved a 0.93 correlation with the gold standard teacher, the ChatGPT responses. And this statistically proves that we can balance aggressive jargon reduction with high fidelity scientific preservation, all on a single consumer GPU. And this is my favorite part now. So the statistics are vital, but a project focused on communication, the ultimate test is obviously people. So to predict a qualitative audit of these models, I held a blind expert review. I recruited 3 of my friends who all have PhDs in microbiome research to evaluate a random selection of 10 abstracts, and I gave all 3 the same 10. And I asked them to score on 5 different criteria. So this was scientific fidelity, clarity, information density, entertainment value, and the appropriateness of analogies. And they simply judged the quality of the journalist persona. And this was the final cherry on the top of my project, I think. And it moved beyond just simple token matching to true expert validation of this domain. So the results of the blind audit provided the ultimate validation, I think. As you can see in panel B, my fine-tuned llama model achieved a near perfect parity with the GPT teacher standard, and both models maintained identical median aggregate scores of 21 out of 25. And this represents a massive leap over the base model score of 13. And then looking at the individual categories in panel A, I was particularly proud to see that the model matched the gold standard, the ceiling of scales for scientific fidelity and clarity. And this proves that we successfully bridged the performance gap, creating a model that maintains rigorous integrity while being highly accessible. And then a subtle divergence did emerge in analogy and appropriateness, where the higher standard deviation suggests that while it's mastered the factual preservation, generative creativity, the context-specific analogy is still a variable task for the 3 billion model. However, these results concisely prove that with the right data and the QLoRA strategy, we can produce professional-grade scientific journalism on consumer hardware. So with this, the models excel at stylistic translation. The pipeline is an incredible tool, I think, but we should obviously deal with this with caution, because we are talking about edutainment here and not making any sort of medical and dietary recommendations. For those, we could see moving to a retrieval augmented approach, like a framework that scans full text and supplemental figures, where a lot, as we know as scientists, where a lot of the information is hidden, even the shortcomings of the study, and then adds that to the journalist output and curates it. So in conclusion, this project demonstrated that we can keep advanced scientific communication tools in the hands of researchers by optimating for consumer-grade hardware. I would really like to thank you all for this course. This is actually the 10th of 10 for the data science degree for me, and I can tell you that it's an incredible way to finish it, and I hope that you guys have a fantastic summer. Thank you very much. Bye.